Welcome to the Deep Dive. We're the show that takes a pile of documents and, well, pulls out the crucial stuff for you. Today, we're tackling something absolutely vital in workplace safety, but maybe a bit overlooked sometimes. Confined space entry.
Yeah, it's definitely critical. And the document we're diving into today is pretty heavyweight. It's an environment, health, and safety standard. Comes from a major electromechanical project group, EHSMBG 12, just revised November 26, 2024. So it's current practical stuff.
Exactly. This isn't theory, it's a real-world playbook for managing some seriously dangerous work. Our mission here is to kind of unpack this dense standard. We want to show you why confined spaces are such a big deal hazard-wise and, what kind of really detailed measures are needed to keep people safe.
Think of it as your shortcut through the jargon to the core safety principles.
And the standard pulls no punches right from the start, does it?
No, it really doesn't. It flat out says working in these spaces is among the most dangerous workplace hazards. Even riskier, it notes, than doing similar jobs out in the open.
And we're talking about places like tunnels, shafts, tanks, sewers, places you can easily picture.
And the immediate message is follow the procedures. Strictly. It's non-negotiable for preventing incidents.
Okay, so let's start with the basics before we get into all the rules. What is a confined space according to this standard? It's got to be more specific than just like a small closet, right?
Oh, absolutely. Much more specific. It's less about size and more about the risks involved. The standard lays out 4 key things. First, it's anywhere that gas, fumes, vapor, or dust might be present, enough to potentially overcome someone. So atmospheric hazards are number 1.
Yes, invisible dangers, got it.
Second, it doesn't have effective ways to get in and out. Entry and egress are restricted. That's a big one. Third, it's simply not intended for continuous human occupancy. You're not supposed to hang out in there.
Right.
And fourth, there's a risk of drowning or engulfment by materials that can flow freely. Think grain silos or, tunnels, tanks, pits, that sort of thing.
So it's that combination. Restricted access, potential hidden nasty stuff in the air or materials, and it's not designed for people to be in long term. Makes sense.
Exactly. And the why behind this standard is crystal clear in the document. It's all about worker safety and health, providing really clear steps to identify hazards, assess the risks, control them, and of course, meet all the legal requirements.
And just for context, this specific standard, it's for the electromechanical project group sites. But it builds on a lot of other regulations, right?
Yeah, it references relevant Indian standards, things like the Factories Act, BOCW Act, ISO 45001. It's integrating legal rules with, industry best practices. It's pretty comprehensive.
Now, this is where I found it gets really interesting. Who's actually responsible for making sure all this happens? It's not just one safety guy, is it?
Not at all. That's one of the strengths here. It's a really layered approach, a true team effort, multiple people involved.
Oh, web of responsibility.
Precisely. It creates checks and balances. So let's break that down a bit. Starting right at the front line, you have the at-risk employees, their job. Attend the training, follow the safety controls, the ICRA and SWM we mentioned, basically promote the standard themselves, and really importantly, report any new hazards they spot.
So they're empowered, not just passive.
Absolutely. And there's site management. This is group site in charge. Engineers, station managers, supervisors, their list is long. Ensure training, prepare and follow the higher SWM, monitor for gas, make sure only trained people with permits enter, close supervision, have emergency stuff ready.
Wow.
Conduct safety observation tours, SOTs, they call them check PPE use, and maintain the official confined space entry register. It's a lot.
Yeah, that's huge.
Then you've got the project EHS representative. Think of them as a resource and a verifier. They check if the standards being implemented properly, review the permits for compliance, double-check training records, coordinate rescue drills, and do their own SOTs.
Kind of an oversight role within the project team.
It's exactly. Moving up, the project manager and project director, they have a critical role too. They actually check and approve the work permits. They champion the standard, ensure training happens project-wide, and enforce the controls. They also conduct rescue drills and SOTs, and this is key. They review the findings from audits, investigations, even suggestions from employees. It's about learning and improving.
So strategic oversight as well as direct approval.
Right. And then higher still, the delivery head or regional delivery head. They're looking at the bigger picture, reviewing progress in EHS meetings, providing support, and working on improving the standard's effectiveness across multiple projects, potentially.
Okay.
And finally, you have the champions. These are people specifically tasked with driving the standard's success, supporting implementation, evaluating how well it's working through metrics, doing annual self-assessments, finding ways to make the process better, and they're involved in the annual review of the standard itself.
That is incredibly thorough, a whole network.
It is. And it raises that question, doesn't it? How do all these different people make sure safety is consistent and rigorous every single time?
Yeah, how does this translate into action when someone actually needs to go into a confined space? The standard must have a very specific procedure for that.
It does. Very precise, step by step, leaving very little wiggle room. First off, there has to be a master list of confined space, every single one identified. This list is used for the Hazard Identification and Risk Assessment, the HIRA, and gets reviewed and updated monthly.
So everyone knows exactly what spaces fall under these rules.
Exactly. And each space needs clear signage at the entrance with its own unique confined space ID number. Then, before any work starts, the project team must do that HIRA and figure out the specific safety controls needed for that task, the SWM.
Okay, assessment first, then what?
Then comes the critical step, atmospheric testing. Before anyone sets foot inside, the air must be tested. They use calibrated gas detectors, and the results are recorded right on the work permit.
And there are hard limits, right? Like oxygen levels?
Absolutely non-negotiable limits. Entry is flat out not allowed if oxygen is below 19.5% or above 23.5%. That's the breathable range. Also, if flammable gases are over 10% of the LEL, the lower explosive limit. Any higher, and there's a serious fire or explosion risk.
10%, that's a low threshold.
It is. And same for toxic stuff. Things like hydrogen sulfide, if it's over 10 parts per million, or carbon monoxide over 50 ppm entry is forbidden. These gases can incapacitate you very quickly.
And the detectors themselves, they need checking.
Crucial point. They must be calibrated every 6 months. An uncalibrated detector is useless, maybe even dangerous.
Right. Okay, atmosphere checked. What else?
An attendant. A supervisor has to ensure there's an attendant stationed right at the entrance for the entire time work is happening inside. This attendant needs to maintain communication with the people inside and be ready to trigger emergency procedures.
The eyes and ears on the outside.
Exactly. And the supervisor also keeps the confined space entry register updated for every single activity. Records are vital.
And only trained people can go in.
Only trained employees. And they have to follow every condition listed on that permit. No exceptions. Plus, there needs to be an emergency rescue plan, prepared and approved before entry, along with the permit.
A plan isn't enough, you need to practice it.
You got it. Rescue drills have to be conducted at least every 6 months.
Makes sense. Practice makes perfect, especially when lives are on the line.
And equipment inside is restricted too. Anything electrical operating above 24 volts. Strictly prohibited if there's any chance of a flammable atmosphere.
Low voltage only.
Yep. And finally, sites need a detailed list of all the safety equipment used for confined space entry lifelines, tripods, winches, harnesses, blowers, the gas detectors. And this gear isn't just listed. It needs a monthly inspection against a checklist and a visual check before every single use.
Wow, that is meticulous. So, tying this all together is the permit itself?
Precisely, the confined space work permit. That's the key document. It's not just a piece of paper. It's the formal authorization that confirms all these steps have been taken.
Okay, so tell us about the permit process. Each site has to use one, either the client's or a specific company format.
That's right. And critically, you need a separate permit for each working group, not one permit for the whole space if multiple teams are involved.
One team, one permit, and who signs off?
There's a clear chain prepared by the supervisor or engineer. Then it has to be verified by the EHS representative, that check step, and finally approved by the site in charge or the project manager.
Multiple levels of sign-off.
Yes, and its validity is super strict, valid for only one shift of the day.
Just one shift. Why so short?
Because conditions inside a confined space can change rapidly. Atmospheric conditions, structural integrity, whatever.
Yeah.
A check for one shift doesn't guarantee safety for the next.
Makes sense. And a copy has to be right there at the job site.
Must be accessible at the work location, always, and night work, generally forbidden. Strictly prohibited, the standard says, except for tunnels, and even then you need special prior permission.
Okay. What kind of details are actually on this permit form? It sounds like a checklist.
It is, essentially, a very detailed one. It confirms things like, is the attendant present? Is all equipment disconnected or isolated? Has the space been cleaned or purged? Are drives, electrical, hydraulic shut off? Then the atmospheric checks. Oxygen levels recorded, CO2, flammables, all checked and within limit.
All the numbers, basically.
Yes. Plus, confirmation that only 24V equipment is being used if needed, that ventilation like exhaust fans is provided, that air is being monitored continuously, that the rescue plan and gear are in place, supervision is constant, and it lists all the required PPE, SCBA, which is the self-contained breathing apparatus for air supply, eye protection, hard hat, safety shoes, harness, and crucially, the names of every single person authorized to enter.
So it lists the people, too.
Yes. Accountability. And one more really important point about the permit.
What's that?
Its scope is limited to entering into confined space. If you're doing actual work inside, welding, cutting, electrical work, you need other relevant work permits in addition to the confined space entry permit.
Ah, so it's layered. The entry permit gets you in safely, but the work permit covers the specific job hazards.
Exactly. It's a dual-layer safety net.
Okay, so that covers the procedures for entry. But how does the standard ensure the safety culture sticks? How does it maintain safety long-term and, keep improving?
Good question. It's built around ongoing systems, not just one-off procedures. Training is a big part. Employees need confined space training before they're ever assigned the task. And then, annual refresher training is mandatory.
Keeps it fresh in their minds.
Exactly. And attendants and supervisors, they get specific, extra training focused on the standard and their responsibilities.
Makes sense given their roles. What about the management side?
There's several layers there, too. You've got regular leadership reviews, key performance indicators, or KPIs, get reviewed monthly by all those roles we mentioned earlier. Delivery heads, PDs, PMs, EHS leaders, champions, keep safety visible at the highest levels.
So management is actively tracking performance. What kind of KPIs?
They track the number of confined spaces, obviously. But more importantly, they track no of non-compliance of confined space permit. This means looking for instances where work happened without a permit, or by untrained people, or without a rescue plan, or without an attendant, or using the wrong electrical gear, or missing PPE. They actively hunt for where the system is failing.
Focusing on the failures to learn from them. Smart.
Very. Then there's management of records. Strict rules on how long to keep things. The master list is kept until the next revision. Permits, monitoring data, entry registers, kept for 1 year. It creates an audit trail.
Accountability again?
Yep. And speaking of audits, there are formal audit requirements. An annual self-assessment on effectiveness of the standard, done by the champions and EHS leaders. The standard itself isn't static either. It is a standard renewal process. It gets reviewed and revised as needed, at least every 3 years, so it stays current with best practices and technology.
A living document.
It has to be. And finally, if for some reason a site needs to deviate from the standard deviation, it requires explicit authorization from the top, the sponsor and the corporate EHS head. You can't just decide to ignore parts of it.
That really locks it down. Plan, do, check, act. It's all baked right in. It's clearly not just a document to sit on a shelf.
Not at all. It's designed to be active, integrated, and constantly reinforced.
So, stepping back from all this detail, what's the big aha moment for you from digging into this? For me, it's the sheer, almost overwhelming systemization of it all.
I agree. It's the realization that confined space safety isn't one thing. It's this incredibly interconnected system. Definitions, roles, procedures, permits, training, audits, reviews, every single piece down to calibrating a detector or running a drill is designed to link together to prevent things from going wrong in these really high-risk places.
Yeah, when you lay it all out, you see how every detail matters. So for you listening, maybe what stands out is the number of sign-offs required, or that attendant role, or the strict atmospheric limits. It really shows the level of precision needed for safety in these kinds of jobs, and why having these clear, robust standards is just, well, non-negotiable.
Absolutely.
Okay, let's end with a thought to chew on. This standard puts a huge emphasis on human factors, procedures, training, checks, audits. Given all that, how do you think new technologies, maybe things beyond just better gas detectors, like, say, inspection robots that could go in first, or maybe real-time biometric monitoring for workers inside, how might those kinds of things change, or maybe even simplify how we follow these super complex safety rules in the future?
That's a fascinating question. Could technology reduce the need for human entry in some cases, or provide even more layers of real-time safety data? Lots to think about there.